folks, welcome to session 3, and in this session I will be looking at the problem 130. So I would like I would like you to look into the problem data set that I have uploaded on the Blackboard. And as I said before, this data set is drawn from several different books, also includes your book. Okay, scroll down to the last problem 130, and in this problem the situation is trying to look for a replacement for a machine that they have at present. So they are looking at two proposals. The first proposal is to go with machine A. The second one is to go with machine B. Okay, the machine A, the fixed cost is 65,000, machine B is 72,000, variable cost to produce is 22 and 17 here. The selling price, regardless of the machine A or machine B that you go with, the selling price is the same, $32 a piece here. Okay, and what is asked for in the problem is several different things. The first question is to find the break-even quantity. The second one is to express that in terms of the dollars. Okay, let's address those two problems first, and as we did before, get the total revenue. The total revenue is nothing but drawn from the units sold to with respect to the selling price, the combination, and over here you have to refer that properly. Quantity sold times the unit selling price, and likewise the total variable cost like before, quantity times the variable cost per unit, and the total cost is the sum of the fixed cost plus the variable cost. As we did before, profit is the difference between the revenue and the total cost. So now here we have those two situations. The problem A calls for what is the break-even quantity for each one of them. Break-even quantity is a quantity at which neither you are making profit nor you are incurring loss. What is that quantity? In other words, we just recoup the fixed cost that has gone in. So this is a sunk cost that we recover. That's the break-even quantity. Now what I'm going to do is I'm going to use a goal seek to get the break-even quantity. What I want to do here is I want to go blank this out, these two areas, then go here, go to that place, go to data, what if analysis, goal seek. Goal seek is what is the value. The changing cell is going to be the quantity, and the set cell is going to be the profit, at which we are looking at a profit of 0 for that quantity. What is that quantity? Set that to 0, click OK. We get 6,500. Click OK. And then let's just write down 6,500 there. Okay, and just like that, come here and do the goal seek again for machine B. The target cell is the profit for machine B, and that value is 0. What is that quantity? That is a changing quantity. What is that quantity that's going to drive that to 0? That is 4,800. Okay, so let us translate that 4,800 here. So now 6,500 is the minimum production level to recover that cost. Here it is 4,800 to recover that cost. In terms of the dollar amount, that is expressed as the quantity times the selling price, which is the 6. Now in this case, in terms of the dollars, that volume is the break-even quantity times what is that revenue at which you break even times the selling price. That is that part. Okay. The second, that is part A and B of the problem. The part C basically says if your production quantity is at 5,500 level, 5,500, which one would you go with? Okay, so what I did was I just copied the entire thing, pasted over here. Now you just have to know, once you have the model in place that draws the relationship between the profits and the cost over here, like how we have, like that's total revenue, etc. You just go insert whatever the quantity here is, then note down the profit. Based on this profit, you want to go with machine B. Okay, you want to select that because that gives you the highest profit. Select machine B. Now, what if it is 7500? Now, I can go back and change it right here, or you can just copy the entire thing, paste it over here, change that to 7500 and note down the profit. Even at 7500 level, machine B still is the most profitable one. You select that. Okay. Now, the last problem, the part E of the problem asks for what is that break-even quantity. Now, what is that quantity at which you are indifferent between the choice for machine A as well as machine B? In other words, we are looking at what is that quantity at which the profit from both of these would be same, or loss from these two would be the same. Okay, so what is that quantity in terms of the graph? So what I have done is go back to your session A, your first session, I'm sorry, and go back and see how we use the data table to create for various quantity level what is the profit from this and profit from that. So what you have to do is you have to draw the reference to where that profit for machine A is written. So I'm using the second model over there, and likewise for machine B, that's where it is. So what it does is it takes quantity one at a time, inserts the quantity here, and here I have drawn the reference because in data table it can insert the value at only one place. Now here we want the same value to go at two places, so since it can insert at only one place, just give one reference like here in that data table. Then in the next cell over here, give the reference to that. So whatever quantity that's written here would also go there. Now, once you create the data table, just like the way that I did in session 1, select this first, then hold the control button and select this, then go to the insert, then the scatter plot and locate this. Okay, then once you do that, this graph basically gets drawn, and go back and change the legend as we did in session 1. Refer back to that as how to do it. Machine A, machine B. So here we are in this problem looking at this quantity at which, look at this crossover point. At this point, the profit or loss from both proposals would be same. So what is that quantity? See, on the x-axis is the quantity, the y-axis is the profit or loss. Now we are looking at this quantity. So this quantity is way less than 5,000. What is that quantity? So what I'm going to do over here is I'm just going to copy the model that we already have created over here, and just like the way before, I'm going to use the goal seek. In goal seek, just like in data table, the value can be inserted at only one place. So since I'm looking at the quantity that is the same for both, so this is where I'm going to do it. Here I'm going to draw the reference to that cell, and that does it. And since the profit or loss is the same, what I'm going to do here is I'm going to create a cell here, difference in profit, which is the difference between that and the difference between the profit from machine B. So I'm looking at a crossover point. Since the profit or loss is the same, so their difference should be equal to 0. So I'm going to use that. Go to the what if, goal seek. So the target cell, let me just draw the target cell right there. The target cell, which is the difference in profit, that is the same, which should be 0. And what is that quantity? And that quantity, what is this quantity that's going to get us the same profit for both proposals or loss for both proposals. So since I draw the reference to that right over here, it gets inserted right there too. So it calculates as it goes through, it takes different values, same values inserted here as what it is here, takes the profit and keeps on iterating until it hits the same value here, and that value, then difference would be 0. Click OK. So as you see, it went through all that thing. At 1400, both of them result in the same amount of loss. Click OK. In other words, both proposals incur loss at this quantity, which we usually call quantity of indifference because you are indifferent between both proposals. So folks, just note that what we did here is part E of the problem and not part D of the problem. I just copy and paste. I forgot to change that. Now I have done it. Okay.